Today, we are going to be connecting the XGPM software to the EtherCAT motion controller and pulling SDO information from our EtherCAT servo drives. In previous help topics, we have physically wired up our EtherCAT network, and we have created projects in both XG5000 and XGPM. Now let's take a look at configuring our axes in the XGPM software. Remember that we are building a 3-axis motion system that will have an X, a Y, and a Z axis working together as part of a tabletop gantry system. We have manually set the node ID rotary switches to node 1 for the first drive, the X axis, node 2 for the second drive, the Y axis, and node 3 for the third drive, which will be the Z axis. We have XG5000 and XGPM open and have already read the blank project out of the PN08B EtherCAT module connected to our CPU. It's also important to note that the software uses node and slave interchangeably. They both refer to the devices on the EtherCAT network that are not the master. To start our configuration, let's have our master grab the configuration information from the EtherCAT nodes on the network. To do this, we need to have the PN08B module selected in the project window. If we have selected the onboard step and direction motion controller, this next step will be grayed out. Once we have the proper selection in the project window, we can go to Online, EtherCAT Slave. We see that we have options to connect to all slaves, disconnect to all slaves, and autoconnect. We will select AutoConnect. This opens the Network Slave AutoConnect pop-up window. In our previous video, we read the SDO files during our Open from PLC step. That function pulls the SDO files stored on the PN08B motion module. Using the AutoConnect function, we'll scan the nodes connected to the network, pull their SDO files into the motion module, and then read them into the XGPM software. While AutoConnect reads the most current SDO information directly from the nodes, at times it is useful to compare the SDOs stored in the motion module and the current SDOs in the drives to each other. The software gives the option to access both. Because AutoConnect overwrites the saved SDOs in the motion module and software, you will need to save an offline copy of your XGPM project prior to executing the AutoConnect if you want to compare the files. In our example, we don't care about the files already in the motion module, so we will make sure the checkbox to read the SDO files from the network, as well as the box for matching the slave station and access numbers together, are checked. Once we hit OK, the software will scan the EtherCAT network. It then gives us a confirmation message once the process has been completed successfully. We see the 3 slave drives have been added to the project window on the left side. We can also review their SDO files. If we double-click on SDO parameter for slave 1, it will open the new1.slave1.sdo. New1 is the default name given to the PN08B card. If we renamed that card in the software to something more specific, the naming convention in this window would change also. We can now look at parameter 2003:00 for slave 1 and see that the node ID is 1. Let's perform this same check for axis 2, and we see that it is node 2, and finally for axis 3, and it is set to node 3. Perfect. The software offers one final feature to help prevent drives being hooked up in the wrong order. By default, if the PN08B sees our 3 configured node numbers on the network, the controller will match the slave number in the software up to the node number. It will not matter which order the nodes are connected in. In certain situations, hooking the drive Ethernet cables up in the wrong order could cause motion commands to be sent to the wrong physical servo motor. To help prevent this, the node number enforcement option in the software will require the node numbers be hooked up in the same order as they are mapped to the slave numbers in the software. To enable this option, we will go to the project window on the left side and double-click on Master. We will then set the Use Node Switch value to 1, Used. In our case, since slave 1 is node 1, slave 2 is node 2, and slave 3 is node 3, the EtherCAT port on the PN08B card would have to be connected to the in port on the node 1 drive. The out port on that drive would have to be connected to the in port on the node 2 drive, and the out port on the node 2 drive would have to be connected to the in port on the node 3 drive. Connecting them in any other order will cause the controller to fault. It assumes a wiring mistake was made. If we had slave 1 mapped to node 3, slave 2 mapped to node 1, and slave 3 mapped to node 2, then the physical wiring would have to have node 3 first in line, then node 1, then node 2. This is one final physical security feature to prevent motion going to the wrong physical axis, potentially avoiding personnel injury or equipment damage. We strongly recommend you utilize this feature in your EtherCAT network. With all these diagnostic features active, we can replace a drive in the future with a lot of peace of mind. For the network to function, the drive will have to have the rotary switches set properly and be installed in the correct network position. Exactly what we want. Perfect. We can now save the project. Let's also write the project to the CPU and motion controller. XGPM will not write all of the data to the EtherCAT motion card if the EtherCAT network is connected between the master and the nodes. Depending on which version of XGPM is used, the network may or may not be connected when the autoconnect step is run. To find out if the network is connected, we go to Online, EtherCAT Slave, and we can see that we have the option to read and write SDO files for the nodes. If we weren't connected, this function would be grayed out. To disconnect the EtherCAT network, we will select Disconnect All Slave. This will give us confirmation when the disconnection is successful. We can then click the icon of a laptop with an arrow pointing to a PLC, or we can go to Online, Write. This will pull up the Write Project window, where we can select what information we want to write. We aren't doing anything with the XEM CPU's onboard step and direction axes, so we will leave that section unchecked to save write time. Let's just check the box for the PN08B and then click OK. This will cause the software to warn us that SDO files are not written with the rest of the project. In our case, that is fine since we haven't made any changes to the SDO files yet. If we had, we would need to write the SDO files to the network nodes after completing this write. We will cover performing an SDO write in a later video in this help topic. Please refer to it for further details.